In this section, we'd like to give another short example of our capacity analysis. So here we have a process flow diagram for an office chair. We have 3 steps in our line. We have no inventory between the steps. We have here a base process, so presumably putting together the base of the chair takes 6 minutes per unit. Then we have an upholstery step in our process, which is putting together the cushioning. That takes 10 minutes per unit. And finally, a final assembly for the finishing the whole chair, 8 minutes per unit. Now, first question is, what are we going to use as our flow unit? So answer A is the base, answer B is the upholstery, answer C is the office chair itself, and option D then is a batch of 6 office chairs. And here it should be fairly clear. We're not talking about the individual parts of the chair. We're talking about the final unit, the office chair. We haven't talked about any batches yet. So we're going to look at our unit, our flow unit of an office chair. And then we're interested in then how long does it take our office chair to move through the process, and what is our process capacity? How many office chairs can we make per unit time? Maybe we can quickly answer the first one. How long does it take for your office chair to flow through the process? Well, this entire time is going to be then 6 plus 10 plus 8. So you're looking at 24 minutes as your flow time through your process. All right, now we want to look at the capacity calculations. What is the capacity of the base process in units per hour? So be careful here, it wants units per hour. So base. Now what did we say? The resource capacity is equal to 1 over the activity time, or we called it P. So here we have P equal to 6 minutes per unit. So at the base, the resource capacity is equal to 1 over 6, and that's units, or chairs, per minute. We multiply that by 60 minutes per hour, and we get a total of 10 units, flow units, chairs, per hour. So we have here the resource capacity, and units per hour is going to be 10 units per hour at the base. Now the next question, of course, is where's the bottleneck in our process? So again, the bottleneck is the resource with the lowest capacity. So what do we have here? Again, the resource capacity here was equal to 10 units per hour. Here we would say 1 over 10 times 60 minutes per hour is going to be equal to 6 units per hour. And here we have 1 over 8 times 60 minutes per hour, and we end up with 7.5 units per hour. So where's our bottleneck? Well, we can clearly see at upholstery we have only 6 compared to 10 and compared to 7.5. So 6 units per hour at upholstery is our bottleneck. Now we could have done that much more quickly, right? Because we simply saw this was the longest activity time. So the resource or the activity that has the longest activity time is going to be our bottleneck. Now, here we have that written out one more time. Now, just to emphasize one more time, we're assuming that we have enough raw materials so that we're not constrained by any raw material and that we have plenty of demand. So this is our customer. Must be somebody who needs an office chair. Can't really draw that, but the office chair supplier or the person who's buying the office chairs, we have sufficient demand. Now, the other definitions we had in the earlier lecture, the process capacity is going to be the capacity of the bottleneck. It's the minimum resource capacity in the process. So what do we have for that? Well, we have the upholstery, and this had then a capacity, process capacity, equal to 6 units per hour. We calculated earlier. That is our process capacity. And then just to emphasize, the flow rate in this example is also equal to the process capacity. The rate at which we are producing, so units per time, we're assuming we have enough raw materials and we can sell every skateboard. So this flow rate is also going to be equal to 6 units per hour. Now, of course, that would change if we didn't have enough raw materials or we couldn't sell everything. But for these examples, we're considering the flow rate equal to our process capacity. So the next very interesting thing was the resource utilization. So we've got a rate here of flow rate equal to our process capacity. For this example, capacity equal to 6 units per hour. Now for each of these then, we want to calculate the resource utilization. So flow rate is 6 divided by resource capacity, here's 10. The base is utilized only to 60%. The upholstery, you don't even need to calculate this, right? It's the bottleneck. So it's going to be utilized 100%, assuming we have enough inputs. Assembly is going to be 6 over 7.5, is going to be then only utilized to 80%. Now, so the resource utilization, very important then. You see that there's idle time for these two resources, whereas the upholstery is working 100%. And here we have that written out also one more time. Resource utilization 60%, 100%, and 80%. Now, again, let's try to do a kind of rough Gantt chart here. Last time I drew this out so it would be so messy. If we say the base, so here's my base, it takes 6 minutes per unit. So time goes by here. 1, 2, 3, 4, 5, 6. Messy, but we have here 6 minutes per unit for our base. So 6 minutes go by, we finished our first base, right? Then we can start on our upholstery, which is 10 minutes. So this is 7, 8, 9, 10, 11, 12, 13, 14, 15. Then we need 8 minutes per unit. Let's use purple. So 1, 2, 3, 4, 5, 6, 7, 8. 8 minutes per unit to finish our first chair. And then this was our flow time here. Equals 24 minutes. Equals 6 plus 10 plus 8. So, now then the question was, where was our bottleneck? Well, we already identified our bottleneck was here, 6 units per hour. So this guy better be working then full time. Chair 2, chair 3, and maybe I can label that also so you can see it. This is chair 1, chair 1, chair 1, chair 2, chair 3. I should be maybe a little bit careful. this doesn't stop there, it keeps going. Now, every time a chair comes out of upholstery, it can go into assembly. So there's it going into assembly, and here we can start then a new assembly here for chair 2, for example, 2. And of course you need to have something to go into the bottleneck, which is going to be the base, and the base is taking always the 6 minutes. So that's for chair 2. This one then goes into the chair 2, and for 3, we can have then the base for chair 3. So what you see here again, and maybe I draw it again with the yellow I used last time, is you've got idle time. Now we only did a part of our Gantt chart here, but you can already see as soon as you start your bottleneck working after the first chair has run through the process, excuse me, here, the bottleneck here, the bottleneck, which is upholstery, will start working 100% in order to keep your maximum possible capacity here of 6 units per hour. And then you're going to have idle time. And that's what we'll be looking at in the other lectures. Thank you.